Howdy! Welcome to Aspire Mountain Academy. I'm Professor Curtis, your instructor for this course in Introductory Statistics. In less than 10 minutes, this video explains how z-scores can help us find probabilities for both standard and non-standard normal distributions. Let's get started. So, the reason why we're looking at these normal distributions is because they represent a really powerful tool in our statistics toolbox. They help us to calculate probabilities and percentiles with relative ease. Now, the old school way, of course, of doing this is to use the z-score tables. So, when we have a non-standard normal distribution, we're going to standardize it and then use the z-score table to calculate out our probabilities and percentiles. Of course, the alternative that we have is using software like StatCrunch, where we just put in the mean and standard deviation values for our non-standard normal distribution, and StatCrunch will do all that conversion in the background for us so we can get out the values that we need for the random variables and the probabilities and percentiles. So regardless of which way you do it, it's pretty simple to get the probabilities and percentile values that you're looking for. So again, you can convert your z-score back to its equivalent non-standard random variable to find the value of interest. So you can do that the old school way, or you can do it using StatCrunch. If we don't standardize the normal distributions, then it's going to be really painful for us to find the probabilities and percentiles that we're interested in for a non-standard normal distribution. What it would require is to find the equation that represents the density curve for our probability distribution, and then we'd have to use integral calculus to find the area under the curve. We'd have to do this for each and every individual non-standard normal distribution. Wow, what a absolute pain. I mean, yeah, okay, so I'm an engineer. I should like math. I do kind of like math, but yeah, I don't really want to do that. Especially when there's something easy like StatCrunch that does all that hard lifting for me. So this is why we have standardized processes, a standardized normal distribution. We convert everything to the standard normal distribution. Then we use our z-score table to give us the values that we're looking for, and then convert back to the non-standard normal distribution values that we're looking for. Of course, something like StatCrunch does all that heavy lifting for us. So I'm all for enjoying the 21st century. So the alternative to using the calculus is that we get a separate table for each specific normal distribution that we're going to use. Again, very painful. So we don't want to do that. We don't want to use the integral calculus. We're just going to use the standardization process that we have, and that's just going to make life a whole lot easier for us. So let's look again at our test score problem that we've seen in a previous mini lecture. We've got this history class exam, and the mean score was 76.8, standard deviation of 2.67. So to calculate the percentile, we're asked for the 75th percentile. I'm going to ask you to pause the video and see if you can get into StatCrunch and make a go of this, and then come back and we'll see how well you did with that. Okay, let's see how you did with that. So again, we're going to use StatCrunch to figure this out. So inside StatCrunch, you have your normal calculator. Notice we've put in the mean and the standard deviation values here in these fields, and we want the 75th percentile. So that's, remember, percentiles represent the area under the curve to the left, because when we were looking at percentiles originally, we wanted all the data values that were less than the data value of interest. So we put 75% here in the probability field. We hit compute, and then here we get the value that's the boundary for that area that's shaded in red. So this is the 75th percentile value that we're looking for, 78.6. Always make sure that you've got this selected. This is the default selection for your inequality less than or equal to, but you want to make sure that that's actually going to be selected here. so that you get the percentile out. So you want to make sure that you're getting less than when you're calculating percentiles. So 70.6 is our 75th percentile value. And again, remember, those percentiles will always be on the left-sided area under the curve. Let's take a look at the same problem, but now we're going to find the 90th percentile. So we just solved one of these problems. You should be able to solve this again with relative ease. So go ahead, stop the video, and go and get into StatCrunch, solve this, and then come back and we'll see how you did. Okay, again, we're going to get into StatCrunch to solve this. So here in our normal calculator, we've got our mean and standard deviation values. I'm going to put in 90%, which is 0.9 or 0.90. Either way, when you hit compute, out comes 80.2. So 80.2 is going to be our 90th percentile value. What about quartiles? Well, quartiles are just specific percentages, or excuse me, specific percentiles, blah, 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 blah. I think I need to go eat some chocolate to loosen my tongue a little bit. So same distribution, but now we want the test score that corresponds with the third quartile. So go ahead, stop the video here, and then go solve it. Come back, we'll see how you did. Okay, let's see how well you did with that. We're going to use StatCrunch to solve this. So inside StatCrunch, here's your normal calculator. We're going to put in 75% here. That's the third quartile, corresponds with the 75th percentile. And then when we hit compute, out comes that number we saw before, 78.6. And that's really all there is to it. Remember, quartiles correspond to the quarter parts of your data set. So the first quartile is 25%. The second quartile is 50%, which is the same as the median. And then the third quartile is 75%. And that brings us to the end of this mini lecture. I hope you found it helpful. You can find more mini lectures for this and other courses at AspireMountainAcademy.com. Thanks for watching. I'll see you in the next video.